All right, so let's get into Santa's workshop and take a look at the main lobby. This is where we're going to take a look at what switch statements look like and how we can identify them. They have a very interesting characteristic that makes them look basically unlike anything that you'll see in x86. So they're really easy to observe. Now, before I kind of begin, in the materials for this on the GitHub page, there's a handout that has nice information about all the things we've kind of talked about before, and some useful shortcuts that I'll be using here and there as we get into stuff, and an ASCII table. Feel free to use it if you think that will be helpful. We're not going to do any more slides. This is sort of just an introductory slide here. We're going to actually jump into the application and then start taking a look at it. When I get into this, we're going to talk about some components and kind of talk about the structure and form of what we're actually seeing. But let's run this first and see what we have. So when you run it, it says, "Welcome to Santa's workshop. You marvel at the grandeur of the main library. You count the keys in your pocket. You have 0. Please select a wing to visit." So in this video, we're going to take a look just at this location, which is the main lobby. So in the main lobby, we have a few different options. We can go to the north wing, the south wing, the east wing, or the west wing. In this particular case, we want to understand what our options are. Perhaps there are other options that aren't actually shown here, and the way that we'll actually find that, rather than just sort of brute forcing, is to take a look at the code. So let's go take a look at the code. For this, I'm going to be using the Binary Ninja demo version. The demo version is free. You can download it. We just can't save the database or any of our analysis that we've done. So what we're going to see here is the control flow graph here. If we press space, we'll be redirected to a linear view. But we'll keep this particular layout because it's interesting to observe the patterns that we'll actually be seeing here. So this control flow graph has set up into various basic blocks, and there are instructions within those basic blocks. Now, it's going to start us at a random location. One of the things that we need to understand is sort of like where this code actually starts and all of the junk that gets compiled around it. Depending on what compiler you're using and which compiler options that you've specified, the compiler is going to throw in support for lots of various features for exception handling and other things that are going on that don't represent the actual code that has been written by a person as a part of a project. It's going to have a bunch of other stuff that we need to sort of whittle down. So one of the ways that we typically do that is finding some anchor point, something to grab onto that allows us to figure out where we need to go or where we need to find information that we're interested in. Obviously, there are a ton of strings here, so we may want to look for things like "please select a wing to visit." That would give us a location of where all this stuff is, or "welcome to Santa's workshop." That's another example of things that we'll be looking for. If we're looking at functionality based, like we're interested in an application that might parse an MP3 file, we would look for system calls that open files or handle reading from files, and then go to all the locations where those are used, and then try to discern, based on all of the things that we see in those patterns, whether or not that's the functionality that we're interested in. If we're lucky, we can debug the application, set breakpoints, throw an MP3 in there, and then see whether or not those breakpoints are hit. If we can't do debugging and everything is completely static, our understanding of the application and the instructions needs to be just stronger, and we need to sort of make good educated guesses based on all the information that we have. So where the heck are we? Where do we go? It turns out that there's a lot of things in here. Not too bad. It's kind of a small application, but we don't want to do this. We don't want to just click around randomly and start just randomly like analyzing stuff. We want to be able to isolate the type of things that we're looking for. Since we want to understand the type of options that are available in the main lobby, we want to use those strings, or attempt to do it. So in this particular case, we're going to look for the "please select a wing to visit." In Binary Ninja, we have this option to go down here to graph and then strings, and then we can type in "please select," and it looks like it's not actually showing up. We have this "please enter pin." So let's look at something else here. We can go to "welcome to Santa's workshop" and see what happens there. welcome to North Pole, welcome to Santa's, here we go, welcome to Santa's workshop. So this entire string is represented as one large kind of blob or mess. If we come down here into the middle, we'll notice that we have no cross references in the bottom left. But if we go to the very start of that string, we'll see that there is a cross reference. And if we go here and press space, we'll look down or highlight over this, and it'll say, welcome to Santa's workshop. You marvel at the grandeur of the main lobby. This is perfect. So what's happening here is we're actually putting something onto the stack and then calling this function, which is printf. This is perfect. This is exactly what we want. If we zoom out a little bit more, this looks good. All right, so what I'm observing here is that we have this jump table. What's happening is we're getting some user input as a part of this fgets and scanf, and then we're going to be comparing that to something and then doing this dynamic reference or this dynamic jump. That's going to bring us to a few different options. And here, Binary Ninja has added these case options so we can sort of discern that this is a switch case statement. But what you'll see is this sort of section where we have all of these blocks, these basic blocks that are laid out in a horizontal fashion all next to each other. There's one block that ends up resolving some location and then dynamically jumping to one of those locations based on user input or based on some calculation that was performed. This is characteristic of a switch statement, so I know that the code that actually generated this main lobby has to be a switch statement. As a matter of fact, as we start going through this, why don't we take a look at the code on the GitHub page and try to verify that that information is correct. So all of the stuff is in here for the different wings. When we're going through and doing this, we typically don't want to look at source code because it's sort of like this handicap that we don't want to have to develop, but let's go ahead and do it. So we have some stuff up here. We have this workshop, and if we look down here, perfect. Here is a switch case statement. So I don't want to go too much into all of this stuff, but I do want to say that this particular setup is exactly what we sort of observe when we go into the application of the binary. Doing this process of developing code and then reverse engineering it or disassembling it and looking at the structure is extremely helpful and lets you spot and identify these patterns. Now, you probably noticed something a little bit interesting, and that is that there are 4 options here, but it turns out that there are 5 options here. When we do this comparison based on the user input, we can right-click, display as, and we can do like unsigned decimal, and it checks to see if that value is over 25. If it's over 25, it's going to jump directly down and just leave this. We don't want it to just leave. What we want it to do is pick one of these values, loop around here, and then bring us back up or call one of these guys and come back. So what we have is some menu that will allow us to constantly reload that main lobby and stay in this application as long as we don't screw up and select some option that doesn't actually exist. So this is 1, this is 2, this is 3, this is 4. This corresponds to those different wings. And then we have a 19 hex. We can display that as an unsigned hexadecimal. We can display that as an unsigned decimal, and it's 25. Weird. So there's a 25 option that doesn't actually exist in here. I'll click 25. It says you wander around aimlessly, sensing you need to collect some keys first. Okay. So it turns out we had to go get some other keys before we actually execute that. But it's cool because we were able to find out that there is some option that exists that didn't show us in the application. And we're able to tell that based on looking at the structure and identifying or correlating this function to this string. So now what I want to do is go up here and press N for name and type in main because this is my main function. Over here now, we'll notice that this is updated. This lets me keep track of everything that's going on. If I had a paid version of Binary Ninja, or if we were using one, then I can save all this information and continue going on from here. I do know that 1 corresponds to the north wing, the south wing, the east wing, and the west wing. So I want to set that information here myself. Now, if we're doing reverse engineering, we're trying to document this stuff, especially if you're working with other reverse engineers and trying to collaborate on databases. Perhaps for a few hours, I start doing some work, save it, someone else comes along, pulls my database, and then starts working with it. there's couldn't be confusion as to if this was named by like some specific symbol that was in here, some like signature, or if it was named by a human reverse engineer. When we do that, and sometimes it turns out that in specific environments, people will decide some flavor or format that they want to name things. In a past malware lab that I worked in, we did Z underscore. This basically just said, hey, if you see the Z underscore in front of a function name, it was actually named by one of the analysts here, and not by IDA Pro or whatever tool that you're using. It's an easy way to sort and also like pull up all the functions that you've named, because you can just sort by name and then all of your Z functions exist right there. So it's up to you if you want to do that, but just a consideration. So in this case, we have the north wing. So go ahead and type in north wing. And then I'll go ahead and do this for every one of these guys. And then finally, for this last one, I'm just going to put Z underscore unc for unknown, because I actually don't know. Now, here's another thing to consider. First of all, can be this sort of intimidation factor when you're reverse engineering something, especially when you have someone else scrutinizing your work and either working with you, working alongside you, or sort of peering over your shoulder, looking at your progress. What you may want to do or may think about doing is sort of freaking out and not making a determination or not committing to defining a specific function, making comments until you're 100% sure that's what's going on. Bottom line is nobody's perfect. Everybody makes mistakes, and there is a certain type of clarity that comes as you start working through different functions, and you'll find yourself redefining names of functions as you sort of understand that it does a little bit more, has a little bit broader context. So pro tip here, never be afraid to name a function or just take a wild ass guess, a wag. Typically what happens is you can name something like Z underscore, I have no idea, but may do something with network, or may parse an SSID or something like that. Just something to give you a little bit of a breadcrumb that says, I've been here before, I've looked at this. And as you see that function called as a cross-reference to something else, you gain a little bit more perspective and a little bit more insight, and then you can redefine that function and rename it. Nobody's going to fault you for doing that. So don't freak out and do what a lot of sort of beginning people do, is they sort of feel this need to be perfect or understand everything completely before sort of committing to a name or committing to the functionality that might exist in an application. Just go ahead and do it. So this is really important concept that I want to talk about here. And we have this function. We have these basic blocks that are all tied together by these nodes, these edges. And the structure of all of this is really important to us. What early reverse engineers do, or people that are sort of like new to this process, is they'll put a binary into a disassembler like this, and they'll say, okay, we're going to push EBP. We're going to move ESP into EBP, and then we're going to AND this, and then we're going to go each and every instruction. You can't do that. There's no way that we can do this entire application. Even though this is a really small application, it'll take us forever. So what we need to do is find the interesting bits, the things sort of existing in the trees, not in the weeds, that are interesting to us. So if we zoom out further, what we can see is this really interesting view. And this view is, we basically hit Control and zoom out. This view is really important to us. And what I like to consider it as, and I don't know, this is certainly not a common thing in reverse engineering to talk about this, but it's this concept of Gestalt. And Gestalt is something that's used in design, and actually I heard about it first in bird watching. Essentially what happens is there's this concept that we can take a bunch of different pieces and organize them in a way that is characteristic of a full or greater form without actually understanding or having the pieces that represent all of that. So there's an article on Medium about Gestalt and what all this means, and the principles of Gestalt and UI design. And there's this really cool picture here of a Dalmatian, and it's just a bunch of blobs, like a Rorschach test or something. We have all these blobs here, but I can pretty much tell that this is a Dalmatian, and we don't have to like really know all the different edges or pieces of all of this. In fact, this poor dog has no paws, but we can still tell that this is what's going on here. The World Wildlife Federation Foundation, WWF or wrestling or whatever, it has this panda, which also has these same concepts. And we can tell that this is a panda, even though we don't have all the lines and edges. In birding, this refers to the characteristics of certain birds in flight or in trees where you don't have every piece of information available to you. So this is a picture from a book called Hawks at a Distance. Identification of migratory raptors. So the idea is if you have birds that are migrating past the bounds of like sort of like where they normally live and hunt, and they're on their way to a different location, and you look up in the sky and you see one, you can't really tell based on like the plumage or like the color of the eyes, which all of these things can be very important into identifying the species or the age of a bird. When they're flying up in the air, you look at certain things like what angle are we at here? Can I see that the bird is holding its wings straight out like a board or more like a V? Is it circling and carrying like flying, riding wind currents? What are the areas, like what are the things around? What's the relative altitude that it's flying? All these different pieces of information help us make an identification of what that bird possibly could be. If its wings are like a V, it's probably a vulture as opposed to like a red-tailed hawk that holds its wings straight out like a board, right? There are certain characteristics that are defining, and just knowing small bits and pieces like that can help you make a positive identification. So it's very much the same thing in reverse engineering, where we have this concept of control flow and structure. And just by being able to understand the pattern of what's going on here, the layout of all of these, and how things are broken up, can give us an understanding of what's happening in this function, or at least how things can sort of move around and how data can actually be manipulated and formed without having to go to each and every instruction. It would be like taking a bird and looking at every single little feather and characteristic up close and personal before making an educated guess as to what species that is, versus just seeing it fly by really fast and being able to take a really quick guess, right? So we need to sort of train ourselves to think about what are these patterns that we're looking for, what are the things that are truly important here, and what do we actually like care about. Turns out the things that we care about are the things that we know. I don't know what this function is right now, but if I figure it out by coming in here and trying to look through this, what I can end up doing is naming this function, and then what I want to do is hop to all of these calls and get a sense for what's happening here. And then if I'm interested in one specific call, then I'll start going up in reverse order and start looking at what's actually happening here. This gives me an opportunity to hone in on specific features that I think are identifying for what I'm looking for, and then start looking at every individual instruction past that point. So this is the concept that we're going to try to use when identifying functionality in the rest of this binary. In the next video, we're going to go into the North Wing, and then we're going to talk about how to actually solve the individual challenges and start getting some keys. We'll see you then.